Hydraulic design manual updates. The main takeaway that I want you to get from this presentation is that there is essentially 3 critical updates. And the sheet flow analysis is now required for storm sewer projects. IDF curves have been updated. Storm sewer and culvert maintenance velocities have increased from 2 feet per second to 3 feet per second. The hydraulic design manual release was July 1st, 2016. Is it effective on all projects August 1st in 2016 or later? Sheet flow analysis is now required for all storm sewer projects. This is something that we probably want to consider for almost all of our roadway projects aside from storm sewer projects. The main objective of a sheet flow analysis is not to compromise any existing sheet flow patterns, ensure that the roadway provides storm conveyance for extreme events without significant impacts to structures. This is better depicted by this diagram. You can see that we actually have the storm sewer, which is what we call the primary system. It's designed typically for the 2-year to 10-year event. And then during the extreme events, or let's say if the storm sewer becomes plugged or is unable to flow, then your streets will actually take over and convey the flow to your outlet point. Okay? So the streets would be considered our secondary system. So actually do a sheet flow analysis, all you really need to have is like a contour map. You will delineate your high points and low points of your roadway as well as your road ditches. And once you have those elevations plotted, you can actually determine your actual sheet flow patterns. You'll do this for the existing condition, and you'll also do it for the proposed condition. And then you compare the two together, and you want to make sure that you're not causing any adverse impacts to any of the properties. If you are causing an adverse impact, we do have a couple solutions that you normally would take. In this particular case, you can notice that the VPI at this location is backing water up onto properties. So the easiest solution in this particular case is just lower that VPI. Now you have a cascading effect for the sheet flow. If let's say that VPI is not is a constraint and you're not able to move it, the other option is possibly consider a structural option, and that would be to increase the size of that structure and allow the extreme event to enter structure via inlets at this location. So you want to make sure that you size those inlets accordingly as well. In the more extreme cases of sheet flow analysis, you may need to actually consider doing a HECROS. In this particular case, you can see there's a HECROS that is actually a layout of the street, and you actually have the cross sections at the high and the low points along the streets. This is better illustrated in the cross section editor. You can actually see in this particular case, you'll see there's the top of curve, there's a gutter, there's a crown. The right-of-way line, outside the right-of-way line. So you would actually model a cross-section for each one of those low points and high points. And then you would actually put a 100-year discharge into your HECROS model, and you'd run a water surface elevation on there. And you would simply compare that to your critical elevations to make sure that you're not causing any adverse impacts. In this particular case, you can see that there's one structure that is actually flooding, so you would probably go back and revise the roadway accordingly to see if we can get those structures out of harm's way. One other comment about the sheet flow analysis. They're not required in the plan sets, however they are required in your project files, so we encourage you to make sure that you well document the sheet flow analysis. The next update I want to talk about is the IDF curves. They've recently been updated. They were actually based off of TP40, the original ones. And last update was almost 30 years ago, so it's been some time since our last update. The new curves, 2015 IDF curves, are going to be kind of a stopgap until the NOAA 14 Atlas comes online, and we'll talk about that a little later here. The new IDF curves are based off of depth, duration, frequency by USGS. One thing I might want to point out is that report was generated in 2004. So the data sets in that report are probably 3 or 4 years old, so that means your IDF curves are roughly 15 to 16 years old. So in our case, this is just a temporary until that NOAA 14 comes online. The USGS folks, as well as Texas Tech, put together the spreadsheet for the IDF curves. So you've got all your EBD coefficients. You just simply put in your county, and then if you want to, you can put your time and concentration. You can actually generate your intensities. But for most people, they'll be just pulling these EBD lookup coefficients and applying them to their programs. One thing that I would like to point out is that the version of the spreadsheet that we have available now is version 2.1. Make sure that you're using the most current version. Our first attempt, we had some problems with the first spreadsheet. There were some sorting issues, and I think we had about 10 counties that were impacted, and they weren't serious impacts, but still we got that all resolved and cleaned up. The other critical update was minimum maintenance velocities. They've been updated from 2 feet per second to 3 feet per second. We're not sure where the original 2 feet per second actually came from, but the issue is that storm sewers usually have heavier debris, and we think that the 2 feet per second was maybe based off of sanitary sewer design. And like I said, because storm sewers have heavier debris, hence the 3 feet per second. Also, this puts us closer in line with the other municipalities as well as AASHTO. So what's next? Hydraulic design manual. We actually have a couple new chapters coming on board. They will be the chapter on detention as well as coastal. And I would have to say these are going to be some good starter chapters. We'll be adding to them as we move along, especially as we get a handle on the climate science that we're going to be having to deal with in the near future. The other thing that I just mentioned was the IDF curves are kind of a stopgap that we had, the 2015 IDF curves. NOAA 14 Atlas will hopefully be coming online pretty soon. We're thinking on a date of April 2018. We've actually started the project, I think, in May of this year, and we've got basically 4 contributors to this project, and you can see there. We've got Brazos River, City of Austin, Harris County Flood Control District. Of course, TxDOT's handling the lion's share, about 3/4 of the funding, about $1 million for the total project. It's a pretty cool type product. It's all web-based, so this atlas, you would just simply go to the website. You'll select the state that you're interested in, and you can see that right now the state of Texas is highlighted a different color. That's because it's not complete, but all the darker blue are available. So if you're interested in the other states, precipitation data, you can actually get that right now. So you'll be just selecting the state, and then you would just simply drag and drop a crosshair to the location of interest and at your project. And you will select the type of data output that you want. In this particular case, we want precipitation intensity, and it will instantly generate a customized IDF curve for your site-specific, starting with the 1 year to the 1,000-year event. So we're going to have quite an increase in data. You'll be able to simply cut and paste this data right into your software, or you might be just able to just download an Excel spreadsheet right off the web server. The last subject I want to talk about is climate change. We've had a lot of phone calls about this recently. It's still in its infant stage. We think we'll probably start getting some guidance somewhere around 2018. What brought this about was as an executive order 11. It was 13690, which was January 2015. Basically, it requires that all federal projects start coming up with a flood standard that is more resilient to these major events, these storms. And they basically outline 3 different approaches to handle this flood standard. And they seem to be more based for I guess you would have to say structures that have a finished floor slab elevation. If you notice, the first one is freeboard value approach, and all you're doing is taking the 100-year water surface and adding about 2 foot of freeboard to your finished floor slab elevation. The 500-year floodplain, you could pick that approach, and you would just simply assign the 500-year floodplain for your finished floor elevation. And then the climate science approach, and that's the one that seems to be more applicable to DOTs, and that's probably the way that TxDOT will and other DOTs handle this. Like I said, these other two approaches, and in fact, I think the executive order seems to be written in a format that it was kind of for structures like commercial buildings and residential buildings. We don't really think, and this is my opinion at this stage, that these are actually applicable to the roadway design and bridge design. And you think about it, it wouldn't be, because we have a lot of bridges, of course, that are designed for overtopping. We also have, as I mentioned in the sheet flow analysis, we actually have roadways that actually convey the extreme event stormwater. So why would you base those roadways off of these freeboard approaches? So what we think is going to happen is that they're going to ask us to kind of design most of our structures to be more resilient to some of the flooding. For example, if you have a roadway that overtops, maybe at the low points of where it does overtop, that the embankment on the downstream side be armored or fortified. And the same thing, maybe our bridges might be strapped down a little bit tighter or something. But aside from that, I really don't see any significant changes. But I could be completely wrong about that. But we're supposed to be getting comments back from the feds, I think, in the next 6 months. So we'll have a better handle on this in the near future. But regardless, FHWA has made a couple attempts to jumpstart this, and they've actually started addressing the climate science approach. And these couple documents, this one called HEC 17, it's basically the riverine environment, and then you also have HEC 25, and that one was just recently released too, and that one handles the highway and coastal environments. So these two documents will be probably the placeholders for the climate science. So if you want to get ahead of the game, you might want to start reading these two documents to get familiar with them. I think that pretty much concludes my presentation. If you have any questions, one thing I'd like for you to do, if you see any errors in the hydraulic design manual, please forward those comments to me to that address, and we'll see if we can get those taken care of on our next release. So, like I said, our next release will probably be sometime in mid 2017. So you can start looking for those pretty soon. Do we have any time for questions? Great. Any questions? Yes, sir.
What's the update plan for that NOAA Atlas 14? Will that information in the database be updated on a regular basis?
Yeah, that's a good question. The question is, how often will that NOAA 14 Atlas be updated? And I've been told that it will probably be updated every 10 years or so. So let's hope that will be the case as far as the federal funding will be in place to do that.